In this video, we want to take a look at the effect that absolute value has on the graphs of functions. Back in classes before this particular one, you've come to recognize what the graph of absolute value, just a basic absolute value equation, looks like. Probably in your very first algebra class, you were shown the graph of the simple equation y equals the absolute value of x. And since we know that when you put a number in here for x, the absolute value is referring to just its distance from 0, regardless of whether you went to the left on a number line or to the right on a number line. So the graph of the absolute value equation has y values that are all positive, regardless of what the x is. Consequently, we end up with a graph that looks like a big V. But how does absolute value in an equation of degree higher than x, or in the graph of a transcendental function such as the sine of theta or cosine of theta, or things involving those trig functions, how does it affect those types of functions? That's what we're going to look at in this particular video. To begin with, then, let's take a shot at graphing y equals the absolute value of x squared minus 3. Now, there are several ways we could approach this. We could look at it in terms of solving an absolute value equation or an absolute value inequality, but for brevity's sake, let's just think about it in terms of, let's be logical. Let's think in terms of numbers that I can plug in for x that is going to make the x squared minus 3 come out positive, or what numbers for x will make x squared minus 3 come out negative. Well, in order for this number x squared minus 3 to come out positive, x squared has to come out larger than 3. If it comes out exactly to 3, well, then absolute value would equal 0, and that's always a good starting point, is what exactly will make this thing equal to 0. Well, we can solve a little equation, x squared equals 3, and we would get x equals plus or minus the square root of 3. So if we're graphing this by table of values, that tells us that if we put in square root of 3, y is going to come out 0. If we put in negative square root of 3, because when we square it, it comes out positive, y will still come out equal to 0. Okay. Now, 0 is always the dividing point between what two types of numbers? You understand what I'm asking? Think about a number line. 0 is always the point at which you have positive numbers on one side and negative numbers on the other. That's always true. So whatever is causing this 0, we know that on one side of square root of 3 we get positive, and on the other side we get negative, and the same thing with the negative square root of 3, since those two things are the only ones that make only numbers that will make this thing equal to 0. So how do we figure out which way those things go? Well, there are a number of ways to do that as well, but it's just as easy really to approximate this square root of 3 using your calculator and find that, okay, that's a number that's a little bit less than 2. So let's put 2 and 1 into our equation. excuse me here a second, I misspelled 1. It's a good thing that most of the time math isn't graded on spelling, but here. So let's put in 2 and 1. Well, if we put 2 in here, we get 4 minus 3, so the absolute value of 4 minus 3, or 1, would be 1 positive. Now, that means if our theory about 0 is correct, since the number 1 is less than the square root of 3, square root of 3 being approximately, let's call it 1.7, then on the other side of square root of 3, on the smaller side, we should come out with a negative value. Well, if we put in 1, you'll get 1 minus 3 is negative 2. So we actually get the absolute value of negative 2, which comes out 2. Now, if we do the same thing with the negative square root of 3, we know that negative 2 is going to be to the left of the negative square root of 3 on the number line. So squaring it, we're going to get a positive 4 minus 3 is positive 1. So we also get a positive 1. Okay, negative 1 is to the right of negative square root of 3. If we put in a negative 1, we end up again with 1 minus 3, so we end up again with, the absolute value of negative 2, which is 2. So, what we know so far, graph-wise, is that at the negative square root of 3 and the positive square root of 3, we're going to hit 0. If we put in the number 1, we get a positive 2. If we put in the number 2, we come out with a positive 1. So the graphing this section appears to give us that. Now, you also know from your previous algebraic experience that graphing an x squared type function is a parabola, so that it's not going to be just straight lines here. It's going to give us smooth curves. The parabola doesn't lose that particular property. And then if we come over on the other side and do the same thing, and we find that this side looks just like the right side. Excuse my terrible drawing ability here. Now the question becomes, what else happens in between here? Well, we know that on the y-axis, if we put in the x-coordinate of 0, we would get negative 3. So 0, absolute value of negative 3, comes out to positive 3. So the y-intercept is the number positive 3. So, what effect did the absolute value have? Well, we can see here 3 instances where we've demonstrated that when you come out with a negative value for y, in that if the absolute value wasn't there, we'd have a negative value. It makes it positive. So it makes the whole graph be above the x-axis or on it. Now, let me finalize this part just by showing you a better graph. Now, hopefully, you can see more clearly exactly what the effect of the absolute value is on every function that you graph. We can see that the function f equals x squared minus 3 is a parabola that has its vertex at 0, negative 3. Because of the absolute value, that section right here that's below the x-axis gets kicked up above. So, regardless of the graph, that's what absolute value is going to do. So let's take a quick look at one of the trig functions and see how that affects a trig function. Here you see the graph of the cosine function. We can see that it is a repeating cyclical graph, as you know, that as you think about going around the unit circle, it just fluctuates between a high of a positive 1 and a low of a negative 1, and it does that endlessly. So how would absolute value affect this function? If we were doing absolute value of cosine of x, well, then this section would look like the 2 on either side of it, as with this, and every additional negative section would do the same thing, so that our graph would again be a series of points that just kind of bounce repeatedly across the x-axis. So no matter what the function is, when you go to graph it involving absolute value, that's going to be the result. Let me add one additional important concept or comment. Whenever you're graphing an equation that you're not sure what it's going to look like in absolute value, graph it without absolute value first. Then all you have to do is look at the graph and redraw it so that everything comes out on the right side of the x-axis.